China's recent halt in the export of rare earth technologies marks a significant development with widespread implications, particularly for the United States and other Western nations seeking to fortify their strategic raw material supplies. This decision, which comes on the heels of President Biden's resolve to reduce dependence on China for battery materials, adds a new layer of complexity to the global geopolitical landscape. President Biden's recent announcement, aimed at challenging China's dominance in the electric vehicle (EV) market, underscores the growing importance of securing a stable supply chain for key components. However, China's countermove to cease rare earth exports raises questions about the effectiveness of such strategies. The abrupt decision by the world's leading supplier of minerals confronts its geopolitical rivals with the challenge of reducing reliance on materials sourced from China. This move holds profound implications for the EV and renewable energy sectors, given the crucial role rare earth elements play in manufacturing these technologies. As China's decision reverberates globally, it prompts a critical examination of the interconnectedness of nations in the pursuit of sustainable and technologically advanced economies. The true impact of China's rare earth export halt will unfold as nations grapple with the task of diversifying their sources and securing the raw materials essential for advancing industries. This development accentuates the need for strategic planning and cooperation to navigate the intricate dynamics of the global supply chain, especially in sectors vital for the future, such as electric vehicles and renewable energy. The decision to cease the export of rare earth technologies by China underscores the intricate interplay between national security concerns and the strategic importance of rare earths in advanced technologies. While the new regulations do not directly impact the shipment of rare earth products, their underlying purpose may be to obstruct attempts to develop the industry beyond China's borders. Rare earth elements, REs, a group of 17 essential elements, play a pivotal role in manufacturing a diverse range of high-tech devices, military equipment, and green technologies. Their distinctive magnetic, luminescent, and electrochemical properties render them irreplaceable in numerous advanced applications. Notably, these elements are crucial in the production of permanent magnets utilized in wind turbines, electric vehicles, EVs, smartphones, and military defense systems. The significance of rare earth elements extends beyond their applications to being key contributors to several flourishing industries. They are utilized in permanent magnets for wind turbines and electric cars, as well as in critical components of modern electronic devices such as television screens, drones, and hard drives. Their unique electromagnetic properties categorize them as strategic metals, establishing them as indispensable elements in technological advancements. China's decision to restrict the export of these vital elements amplifies the global conversation on the need for diversified supply chains and the strategic imperative of ensuring access to essential raw materials. As nations grapple with the intersection of national security and technological innovation, the role of rare earth elements emerges as a critical factor in shaping the future landscape of advanced industries. In today's tech-driven world, amidst the ongoing global energy transition, there is a growing concern about potential shortages of critical materials, given their irreplaceable role in green technology. The United States is taking a leading role in efforts to diminish China's control over the supply chains of minerals, spanning from rare earths to lithium and cobalt. President Joe Biden's flagship climate legislation includes provisions aimed at increasing domestic or allied nation supplies. In response, China has imposed restrictions on the export of gallium, germanium, and graphite. While Biden's landmark legislation, coupled with Europe's Critical Raw Materials Act, pledges to unlock new funding for potential suppliers, China's recent move highlights the technical challenges Western producers may encounter. These challenges stem from the need to develop refining processes that China has mastered over the decades. Until relatively recently, there were scarcely any rare earth refineries outside of China. This lack of infrastructure means that Chinese companies and researchers have accumulated substantial technological and practical expertise in this domain. China has a distinct advantage in the extraction and processing of rare earths, with expertise that surpasses developments elsewhere. The recent ban, which includes restrictions on technology for separating rare earths, producing metal and magnets, as well as mining, or dressing and smelting processes, underscores China's dominant position. Controlling nearly 90% of the global refined output of rare earths provides China with a substantial technological and strategic edge. China's proficiency in the solvent extraction process for refining rare earths has established a high standard in the industry. By imposing restrictions on the export of related technologies, China has erected a significant barrier for Western countries looking to develop their processing capabilities. The impact of this ban is particularly pronounced in the domain of heavy rare earths, crucial for high-tech applications such as electric vehicle motors, medical devices, and defense equipment. China's near monopoly in refining these materials highlights the vulnerability of Western nations and their reliance on Chinese expertise for these essential components. The restrictions not only disrupt the global supply chain, but also emphasize the imperative for Western countries to invest in and advance their capabilities in rare earth extraction and processing to ensure a more resilient and independent future in critical technologies. In response, Western countries, notably the United States and the European Union, have intensified efforts to develop their rare earth processing operations. However, this transition encounters substantial challenges, including technical complexities and environmental concerns. Companies such as MP Materials in the U.S. and Ucore Rare Metals in Canada are leading these efforts. Ucore, for example, has achieved significant progress with the commissioning of a facility for testing its rare earth processing technology, partly funded by the U.S. Department of Defense. Ucore's CEO, Pat Ryan, asserted that new technologies are essential to overcome China's control in these critical areas. Don Schwartz, the CEO of American Rare Earth, emphasized that China's determination to maintain market dominance has turned this into a competitive race. The impact of China's export ban on the electric vehicle (EV) market is noteworthy. Beijing's restrictions coincide with reports that the White House is contemplating higher tariffs on EVs to counter China's dominance in the sector. China presently stands as the world's primary player in EV production and supply chain control. The export restrictions on rare earths pose a significant challenge for Western nations seeking to bolster their domestic EV industries and reduce dependence on China for essential materials. As geopolitical competition intensifies, the race to develop independent capabilities in rare earth processing becomes crucial for securing the future of the EV market. China stands as the world's largest electric vehicle (EV) manufacturer and the primary sales market for these vehicles. While the new rules imposed by China may not directly impact shipments, the associated restrictions could present obstacles for other countries, increasing the cost of developing technology for growing their green industries. If the United States were to implement tariff hikes on EVs against China, potentially escalating their trade tensions, Asian firms could face adverse effects. Many of these companies rely on Chinese technology and parts for their EVs, and any disruption could lead to reduced sales in the crucial American market. For Asian EV firms and related industries, the need to scale up production and sales in the coming years is essential for the commercial viability of green technology. Lack of access to key materials and markets could pose a significant threat to their ambitions. The importance of EV battery technologies extends beyond transitioning away from fossil fuel-driven cars. It also impacts the development of renewable industries such as solar and wind, as well as efficient electricity transmission. As the global push toward sustainable practices intensifies, the interconnected nature of the EV market, renewable energy sectors, and international trade underscores the need for strategic planning and cooperation. Access to essential materials and markets plays a pivotal role in shaping the success and ambitions of industries aiming to drive positive environmental change. The global commitment to triple renewable energy output by 2030, as articulated in the recent COP28 climate conference, involves pledges from 120 nations. This ambitious goal thrusts the humble electric vehicle, EV, battery, and related grid infrastructure into the spotlight. According to Chris Coate, Vice President for Sector and Thematic Research at MSCI ESG and Climate Research. Coate emphasizes that readiness is paramount, stating, "Ready or not." Research indicates that for every dollar spent expanding wind and solar, an additional 80 cents of investment is required for supporting technologies. Cumulatively, this translates to investments of $1 trillion for manufacturing batteries used in EVs and renewables like wind and solar alone by 2030, more than 4 times the investment needed for developing transmission and distribution infrastructure. While this projection may seem ambitious, the promising outlook of China's EV market supports the global transition toward clean energy. A Bloomberg report suggests that half of China's new passenger vehicle sales will be electric by 2026. This statistic underscores the pivotal role China plays in shaping the trajectory of the EV market and, by extension, the broader landscape of clean and renewable energy. As nations worldwide align their efforts to meet renewable energy targets, the focus on EV batteries and associated technologies becomes crucial in realizing these ambitious goals. The interconnectedness of clean energy initiatives, EV adoption, and supportive infrastructure highlights the need for coordinated and strategic investments on a global scale. Globally, the proportion of electric vehicle (EV) sales is set to rise to 16% by next year, up from 10% in 2022. Recent data indicates that China's EV sales alone will displace around 300,000 barrels of oil in 2024. As Asian countries aspire to expand their EV and green industries, they must navigate supply challenges arising from the U.S.-China trade tensions. One approach is for these countries to maintain cordial trade ties with both economic giants to minimize supply disruptions. However, the unpredictability of global supply chains, exemplified by the pandemic-related disruptions, underscores the importance for Asian economies to build self-reliant green industries, including EVs. Several Asian countries are taking steps to bolster their EV and green industries. Indonesia, for instance, is encouraging international companies to leverage its vast nickel reserves for EV manufacturing. Meanwhile, India has announced EV production-linked incentives. Despite these ambitions, these economies face numerous challenges requiring a comprehensive set of measures, including manufacturing incentives, tax rebates, and supportive policies. Developing technology and fostering a robust ecosystem for EVs and green industries will be crucial for these nations to achieve self-reliance and sustainable growth in these strategic sectors. In various industries, the supply of lithium-ion batteries, a cornerstone for electric vehicles, EVs, is expected to fall short of the surging demand in the coming years. Some EV companies are proactively exploring alternatives beyond lithium, turning to more abundant minerals like sodium for battery manufacturing. The uncertainty surrounding the extent of China's rare earth technology export emphasizes the geopolitical intricacies of this situation. Beijing's recent move can be seen as reinforcing a long-standing policy rather than introducing a new restriction. The strategic importance of rare earths amid the global energy transition and national security concerns is prompting Western nations to seek alternative sources and develop indigenous technologies. The current situation underscores the imperative for strategic measures by Western nations to reduce reliance on China's dominance in this sector. Developing independent supply chains and investing in technology innovation become crucial steps in this direction. This may involve the exploration of new rare earth mining sites and substantial investments in research and development to secure a more resilient and diversified supply chain for critical materials. The rare earth dilemma, exemplified by China's recent restrictions on the export of rare earth minerals, highlights broader concerns in international trade and global politics, emphasizing the necessity for diversification and resilience in critical supply chains. It serves as a reminder of the intricate linkages between resource control, technological advancement, and geopolitical power. As the world grapples with these challenges, the evolution of the rare earth market will be a key factor in shaping the future of the electric vehicle, EV, and renewable energy industries. The situation calls for a balanced approach, combining immediate tactical measures with long-term strategic planning to ensure a stable and sustainable supply of these indispensable materials. China's decision to halt the export of rare earth technologies marks a significant turning point in the global dynamics of strategic materials, underscoring the need for concerted efforts by Western nations to develop alternative sources and technologies, ensuring a secure and independent future in the critical sector of rare earth elements. As we move into an electric future, China's recent restrictions on rare earth minerals raise important questions about the global landscape of critical materials. The impact on the rest of the world will depend on how nations navigate these challenges, innovate in alternative technologies, and collaborate to secure stable supply chains for the essential materials driving advancements in EVs and renewable energy.